Hello, and this is our next lesson on coordinate geometry, and we are going to be looking at the gradient. So the gradient of a line is a measure of its steepness, and you may have seen either of these two formulas before, possibly both. And to work out the gradient, it's the rise over the run, or if we do it using coordinates, y2 minus y1 over x2 minus x1. If a line is sloping upwards, it has a positive gradient, and if the line is sloping downwards, it has a negative gradient. And the gradient of a horizontal line is 0, and the gradient of a vertical line is undefined. So a straight line, because as it gets steeper and steeper and steeper, that gradient is just getting bigger and bigger and bigger and closer to infinity, and because infinity doesn't exist, a straight line is undefined. So example 1. We are going to draw a line with a gradient of -2, 3 through the point 2, 4. So I've already got some axes drawn here, just to make it a bit quicker so you're not having to watch me draw axes. It has to go through the point 2, 4, so I'm going to start with plotting that point. Okay, now our gradient is -2, 3. So the first thing we should be seeing is that it has a negative gradient, which means it is sloping downwards, so it's going to look something like that. Now, we don't have any other coordinates or anything like that, so this means that that 2 is our rise and the 3 is the run. So it's going to be moving 3 steps horizontally and 2 steps down. So from here, it means we can plot some more points. So from this point 2, 4, it's got a run of 3, so 1, 2, 3, so that will go to 5, and it's going down by 2. So another point would be there. Then it has a run of 3, 1, 2, 3, and it's going down by 2. So it will hit that point. And from there, then we can just join our dots. And so that's a line that has a gradient of -2/3 and goes through the point of 2, 4. Now, if we want to work out what a gradient is, so we've got to find the gradient of the line 3, -2, and 6, 4. So this line goes through those 2 points, and we want to find what's the gradient. So when you're working out the gradient, you can pick any 2 points in a line. It doesn't have to be 2 specific points. Obviously, we've already got 2 points for this question, but if you were given a graph of some sort, then you can pick any 2 points in the line that you can see, and you will get the same answer. So remember, our gradient formula is m equals y2 take y1 over x2 take x1. So if we look at our points here, I'm going to have this one as x1 and y1, and this coordinate can be x2 and y2. So we'll work this out. Y2 is 4 minus y1, which is -2, all divided by x2, which is 6 minus x1, which is 3. 4 minus -2 will just be 4 plus 2, which will give us 6. 6 minus 3 is just 3, and then 6 divided by 3 is 2. So our gradient of the line that goes through those 2 points is 2. Okay, example 3. Find t, given that the line segment joining the coordinates 5, -2, and 9t has a gradient of 2/3. So we've got these 2 coordinates. So once again, we can see that this is going to be x1 and y1. This is x2 and y2, and we know the gradient is 2/3. We can use our formula, so we're going to know that 2/3 is going to equal y2 take y1, so t minus -2, divided by x2 take x1, so 9 minus 5. So 2/3, t minus -2 will be t plus 2, 9 minus 5 is 4. And then we just have to solve that. So you're going to have to cross multiply. So we're going to have 4 times 2 on this side, and then multiply the 3 up to the other side. And then solve this. So 4 times 2 is 8. Multiply out the brackets here. So we'll have 3t plus 6. Solve that. 8 minus 6 is 2 equals 3t. And then so t will equal 2/3. Okay, it's just a coincidence that the gradient and the t value are the same. There's no special reason for that. That's just a coincidence. All right, That is our last example. So now you can go do exercise 9C from your coordinate geometry booklet. Remember, sure, you're working. Some of this stuff you just need to be really methodical so you don't make mistakes, especially when it comes to negatives.